Following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, today we're going to be reviewing chapters 8 and 9 for the final exam. So let's go ahead and get started. And all righty. Okay, so this is chapter 8. It says let f of x equal 9x plus 8 and g of a equal a squared minus 4a plus 4 all over 9. Find the function value g of 5. So you might be asking, why is f of x equals 9x plus 8 there? We aren't going to be using it. Well, sometimes in life you have to make choices between what's in front of you. So using g of a equals a squared minus 4a plus 4 all over 9, g of 5 would be 5 squared minus 4 times 5 plus 4 all over 9, which is 25 minus 20 plus 4 all over 9, which is, what is that? 5 plus 4, 9 over 9, which is 1. So g of 5 equals 1. So let's put our answer in there and see what it says. It says correct. All right, let's go on to number 2. And let's see here. Okay. Find h of 2 and h of negative 2. So given that h of x equals 3 over x minus 4, h of 2 would be 3 over 2 minus 4, which is 3 over negative 2, which would be negative 3/2. H of negative 2 would be 3 over negative 2 minus 4, which is 3 over negative 6, or negative 1/2, reducing it down. So g of 2 is negative 3/2, and h of 2 and h of negative 2 is negative 1/2. All right, let's take a look at this one. Graph the function. Well, the easiest way to graph this is to think of y equals mx plus b. Y equals mx plus b. We have s of x equals negative 4/5 x plus 1. So the slope is negative 4/5, and the y-intercept is 1. So to graph it, we'll click on the solid line. Again, we don't want the ray or the line segment. We want the solid line. So we're going to start at 1 and go down 1, 2, 3, 4, and over 1, 2, 3, 4, 5. And there we have it. Now, another way you could, oh, it says it's wrong. My point got slightly off there. So I'll come down here and I'll change that to what I wanted that to be, 5, negative 3. So negative 3. Okay. There we go. And again, that shows you how you can fix points, just to remind you. Come in here and check the ordered pairs. All right, let's see here. Another way you could graph this same thing would be to find 2 ordered pairs. So you could say, using s of x equals negative 4/5 x plus 1. You could think of that as y equals negative 4/5 x plus 1. And let's see, how about if we let x equal 0? Y would be negative 4/5 times 0 plus 1, which would be 1. So you'd have the point 0, 1. And how about if we let x equal 5? that gives us a nice number here because the 5's cross out. So then we get -4 plus 1, which is -3. Okay, so doing it this way, 0, 1, and 5, -3. And we can do it that way. All right, moving on. Write an equation for a linear function whose graph has the given characteristics. The slope is 1/4, and it passes through the point 8, 1. Okay. So using y equals mx plus b, we can put the slope in for m. Y equals 1/4 x plus b. We can now take the ordered pair with the x and y, put the 8 in for x and the 1 in for y. 1 equals 1/4 times 8 plus b. 1 equals 8/4, which is 2 plus b. Subtract 2 from both sides, and b equals -1. So y equals 1/4 x minus 1, but it's f of x equals 1/4 x minus 1. So f of x equals, let's see here, 1, let's use a fraction. So 1/4, and then x minus 1. Okay, let's take a look at problem number 5 there. Write an equation for a linear function whose graph has the given characteristics. It passes through the points -2, 2, and 2, -12. Well, again, we're going to use y equals mx plus b, but to find the slope, we're going to use the slope formula. So we'll call this point 1 and point 2. So this is x sub 1, y sub 1, and this is x sub 2, y sub 2. The slope formula says m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So the slope is, let's see, y sub 2 is -12, y sub 1 is 2, x sub 1 is 2, and x sub 1 is -2. So we get -14 over 4, which is -7/2. So that's going to go in here. Then we're going to use either one of these ordered pairs to determine b. I'll use this one. So x is -2 and y is +2. So 2 equals -7/2 times -2 plus b. 2 equals, that's going to be what? 7 plus b. Subtract 7. -5 equals b. So we've got the slope and the y-intercept. Y equals -7/2 x minus 5. And it says f of x equals -7/2 x minus 5. So let's put that in. And again, we'll use the fraction key there. So -7/2, move it over, x minus 5. All right. Number 6 says, write an equation for a linear function whose graph has the given characteristics. It passes through the point 4, 0, and it's parallel to the graph of g of x equals -3/4 x minus 8. So it passes through 4, 0, parallel to g of x equals -3/4 x minus 8. Well, the slope of g of x is -3/4. Parallel lines have the same slope. So we're going to use that same slope. All right. So using y equals mx plus b, the slope goes in for m. That's all we're going to use from original g of x. Then we've got an ordered pair, which we'll use for x and y. So then 0 equals negative 3 plus b. Add 3 to both sides. B equals 3. So y equals negative 3/4 x plus 3, or f of x equals negative 3/4 x plus 3. We'll put that in there. Again, I'm going to use the fraction bar. So negative 3/4, move it over, x, and then plus 3. All right. Next one, write an equation for a linear function whose graph has the given characteristics. It passes through the point 10, 0, and it's perpendicular to the graph of g of x equals 5x plus 9. Perpendicular lines have slopes that are negative reciprocals. So the slope of g of x is 5. So the slope of the line that's perpendicular would be negative 1/5. Okay. So y equals mx plus b. We have the slope of negative 1/5. Y equals negative 1/5 x plus b. Once again, we have an ordered pair to use for x and y. 0 equals negative 1/5 times 10 plus b. 0 equals, that reduces down to what? Negative 2 plus b. Add 2 to both sides, b equals 2. So y equals negative 1/5 x plus 2, or f of x equals negative 1/5 x plus 2. I know I'm moving fairly quickly, but I want to get through a lot of examples, and you can always slow down or stop the video when you're watching it, as you know. All right, so let's see here. We're going to have negative 1/5. So negative 1/5 x plus 2. All right. Next one. Write an equation for a linear function whose graph has the given characteristics. Horizontal through passes through 8, negative 39. All right, a horizontal line is always going to be in the form of y equals a constant. A vertical line would be x equals a constant. Okay, but we're dealing with a horizontal line, so it's going to be y equals, well, the ordered pair is 8, negative 39. The y value is negative 39, so it's going to be f of x equals negative 39. All right, let's take a look at the next one. In a proposal to some prospective clients, a housing contractor listed the following costs. Fees, permits, miscellaneous, $16,000. Construction per square foot, $95. Write a linear function that the client could use to determine the cost of building a home having F square feet. All right, so your variable cost is the cost per square foot. So that's going to be $95 times the number of square feet, so 95F. And then your fixed cost would be the $16,000. So that's going to be your original function. So 95F. Make sure that you use the same letters in case, in other words, don't use a capital F. I think that's a lowercase f. Okay, so 95F plus 16,000. Okay, find the cost to build a home having 1,670 square feet. So basically we want C of 1,670 square feet. which is 95 times 1670 plus 16,000. And let's see here on our calculator, we have 95 times 1,670 plus 16,000. And I'm getting $174,650. So 174,650. All righty. Problem number 10. Refer to the given graph to find each value. F of 2. So looking at the graph, we want to know the corresponding y value when the x value is 2. When x is 2, y is 4. All right. Find the corresponding y value when x is 0. When x is 0, y is 0. Find the value of x for which f of x is 4. Well, f of x is y, so where is y equal to 4? Right there when x is 2. Find the value of x for which f of x is negative 2, or y is negative 2. That would be negative 1. Find the domain and range of the function. Well, the domain is all the x values. This graph is going down. When it goes to the edge of the written graph, grid there, that implies that it continues on. As it's going down, it's going over. As this is going down, it's going over. So the domain would be the set of all real numbers. The range, however, goes all the way down to negative infinity, but the top of the range is at negative 3. So it's the set of all real numbers less than or equal to negative 3. Okay, find the domain and range of the function. The domain starts at 0 and goes on forever. So it would be greater than or equal to 0. The range goes down forever. So going up, it would be from negative infinity up to 0. So all the set of real numbers less than or equal to 0. Recall that domain is the x values, range is the y values. Consider the following graph. Is this a function? Well, does it pass the vertical line test? Yes. So this is a graph of a function. Consider the following graph. Is this a function? No, because it is not the graph of a function. If it is not, find two ordered pairs where more than one value of y corresponds to a single value of x. Now, we have to pick an ordered pair that's listed here. Let's see. X is negative 3, y, no, x is negative 2, y is, no, negative 1, 2, 0, 3, and 0, negative 3. Okay. So again, you've got to find two ordered pairs that are actually on the graph. Okay. That violate it being a function. Find the solution set of the compound inequality. Okay. So we've got 7/4 x plus 1/4 is less than 5, and 3x plus 1 is greater than 13. So first of all, we need to solve each inequality for x on the left side of the equation, or the inequality, excuse me. I'm going to clear the fractions. I'm going to multiply both sides of this inequality by 4. So that gives me 7x plus 1 less than 20. Then I'll subtract 1, 7x less than 19, divide by 7x less than 19 sevenths. Okay. Let's see, did I do that correctly? That's a 20, that's a 1, that's a 7. Subtract 1, looks like it, okay. Then we've got and. Over here, I'm going to subtract 1. 3x greater than 12 divided by 3. X is greater than 4. Find the solution set of the compound inequality. Well, this one says x is, oh, now I see. I was bothered by that 19/7. Looking, there's no answers up there that include 19/7. But if we look at the graph of this, so let's say this is 0. 19/7 is what? A little more than 2. So 1, 2, 3. That's what, 14, 5. So 2 and 5/7. It's about here. So we've got this thing and the arrow going that way. And then x greater than 4 would look like that. But we want the intersection, and there is no intersection, so it's no solution. Okay. All right, let's see. How much time have we got left here? Yeah. Okay. Just want to make sure that I have time to get to the other chapter. I think I'm going to do this one. Okay. Solve the compound inequality, graph the solution set if one exists. So we have 7 less than 3x minus 2 less than 25. So we need to solve for x in the middle. Anything we do in the middle, we have to do to both ends. So I'm going to add 2, add 2, add 2, 9, 3x, 27, divide by 3, divide by 3, divide by 3, and we get that. Now, in interval notation, that would look like that. Not including 3, not including 9. Okay, let's see here. We did it, and let's do a union. Solve the compound inequality. Write the solution set if one exists. Okay, so 3x less than -6 or x divided by 3 greater than 2. So the first one will divide both sides by 3. X is less than -2. The second one will multiply both sides by 3. X is greater than 6. So x less than -2 would look like that. X greater than 6, let's see, over here would look like that, and I'm not concerning myself with super accuracy. What I've got here is I've got a union, but it's 2 separate pieces. I've got from -infinity up to, but not including -2, and not including 6 up to infinity. So let's see here. It looks like the top one is the solution. Now we're supposed to graph that thing. So let's see. We're going to want parentheses at -2, like that. And let's see here. Arrow going that way. And then parentheses at 6 with an arrow going that way. And there we go. All right, let's see. We've done one of those. We've done one of those. Let's take a look at some absolute value problems. Okay, let's see here. Solve the absolute value equation. Enter your answers as a comma-separated list. If one does not exist, enter capital D in E. All right, so 2 times the quantity 4x plus 1, 2 times the absolute value of 4x plus 1 minus 1 equals 17. So the first thing we want to do is isolate the absolute value. So we're going to add 1 to both sides. Then we're going to divide both sides by 2. Now we're going to take it and split it up. We're going to say 4x plus 1 either equals 9, or 4x plus 1 equals the opposite of 9, or negative 9. Solving both both equations, subtract 1 from both sides, divide by 4, x equals 2. Here, subtract 4 from both sides, 4x equals negative 13, divide by 4, x equals negative 13 fourths. All right, so let's check our work. If x is 2, we get 2 times the quantity, 4 times 2 plus 1, absolute value minus 1, 17. 2 times, let's see, 4 times 2 is 8, 8 plus 1 is 9. Absolute value of 9 is 9. So we get 18 minus 1 equals 17, 17 equals 17. It checks. And if we put this in, we would get 2 times the absolute value of 4 times negative 13 fourths plus 1, minus 1 equals 17. 4 times negative 13 fourths is negative 13. Negative 13 plus 1 is negative 12. The absolute value of negative 12 is 12. So we get, what do we get here? 2 times 12 is 24, minus 1 equals 17. 23 equals 17. Let's make sure I didn't make a mistake there. So let's go back, and first of all, let's check the, well, let's see here. I can see the mistake that I made right here. I wrote this as, no, wait, that's right, negative 12. Okay, let's see. 4x plus 4 equals 9. Subtract 4, negative 13. Divide by, get negative 13 fourths. Plugging it in, I get 2 times negative 13 fourths, negative 12, absolute value. Well, let's see what happens. Maybe it just has one answer. So negative 13 fourths. Negative 13 fourths. Didn't like it. All right, hang on. I'm going to pause the recording. All right, I'm back. I found my mistake. It's my sloppy penmanship. Right over here, that should have been a 1, and I wrote a 4. So let's see here. We're going to erase all of this and see if I can correct my mistake. Yeah, sloppy penmanship strikes again. Right there. Okay. Let's try this again. Okay. So now, subtracting 1, we get 4x equals negative 10. Divide by 4, we get x equals negative 5 halves. Okay. So, comma, and then negative 5 halves. What? Okay. We'll pause it again. All right. Apparently I'm having a Monday because I just noticed that one of my solutions was 2. So why did I put negative 13 fourths in there? No idea. Let's try again. Third time's a charm. I don't know what I was thinking. I don't know where I got that negative 13 fourths, probably from someplace I erased. But anyway, which is why you want to check your work before you plug your answers in. I didn't do that because I'm trying to hurry, and here's the consequences of that. All right. Let's take a look at this problem. There's no solution. How do you know? Because an absolute value can't be negative. So D and E capitalized. Let's see here. D, N, E. All right. I am going to go on because I'm running out of time. I'm just going to do one of these problems and then go on to chapter 9. So let's take a look here. I wasted all that time with the wrong answers. My apologies. The property tax in a certain country varies directly as assessed valuation. If the tax is 1620 is charged on a single family home assessed at $90,000, determine the property tax on an apartment complex assessed at $414,000. Okay, so we've got the property tax. Let's call that, how about P, an assessed evaluation. Let's call that V. So it says the property tax varies directly as assessed valuation, P. So P equals KV. Don't forget K, the variation constant. If a tax of 1620 is charged, so that's 1620 is charged on a single family home assessed at $90,000, so 90,000. Determine the property tax on an apartment complex assessed at $414,000. Okay, so we're going to use this equation to solve for K. So K equals, let's see here, 1620 divided by 90,000 comes out to be 0.018. So P equals 0.018 V. Determine the property tax, so that's P, on an apartment complex valued at $414,000. So we're going to take 0.018 times $414,000, and we get $7,452. Okay. $7,452. All right, with that, I'm going to go on to chapter 9. And I'll spend a little bit of time there. You can always come during my office hour if you have any further questions. Okay. All right, this says use a calculator to find the square root. So the square root of 430 says give the answer to 4 decimal places. So square root of 430, I get 20.73644135. 4 decimal places would be here. The 4 would round down, so 20.7364. 20.7364. All right. Simplify the expression. Assume that the variable is unrestricted and use absolute value symbols when necessary. All right. So the square root of 81 is 9. The square root of x squared is x. But because the variable is unrestricted, it could be positive or negative. But since we're taking an even root, it can't be negative. Therefore, we need this. Okay, so let's see how we're going to do this. We're going to put in 9, and then I need absolute value. Let's see, where is that? Functions. Here we go. So we'll put in an x and submit our answer. I want to point out that's one that a lot of people missed on the test. Okay, this one. Simplify the expression. Assume that the variable is unrestricted and use absolute value bars when necessary. Square root of 81 is 9. The square root of h to the fourth is h squared. But h squared couldn't be negative, so I don't need any absolute value bars. So this would be 9. And then, oops, that's right. That's not what I need to do. Okay, 9, and then h squared. And again, make sure you use the same h, so a lowercase h. Okay, let's take a look at this one. Simplify the expression, the cube root of negative 125. Whereas you can't take an even root of a negative number, you can take an odd root. So this would be negative 5. Okay. Now we've got 27 to the negative 2/3 power, which is 1 over 27 to the 2/3 power, which is 1 over 27 to the 1/3 power squared, which is 1 over, well, the cube root of 27 is 3, and 3 squared would be 9. So final answer, 1/9. Let's take a look. It says simplify the expression. We're taking square roots. So if we take 48, we want to find the largest square factor. Well, that's 16. So we could think of this like this. The square root of 16 is 4 on the outside. So we're going to get 4 square roots of 3. Let's take a look at this one. We have the 5th root of 96x to the 9th over the 5th root of 3x to the 4th. Because they have the same index, we can write this as a single radical, 96x to the 9th over 3x to the 4th inside, which gives us the 5th root of what? 32x to the 5th. And 32 is 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32, so 2 to the 5th. So we've got the 5th root of 2 to the 5th x to the 5th, which would be 2x. We don't need absolute value bars because not only does it say the variables are positive, but we're taking an odd root, so it wouldn't matter. All right. Find the domain of the function. G of x equals the square root of x plus 14. Well, you can't take an even root of a negative number, so the radicand has to be non-negative. That is to say, greater than or equal to 0. So solving this inequality, we get x is greater than or equal to negative 14, and in interval notation, it would look like that. So let's see here. I need that. So bracket and then negative 14 comma space. And let's see, where is the infinity symbol? There it is. And then it ends with parentheses. So like that. Oh. Okay, something's not right there. So I need to get that. There we go. That's what I want. Again, make sure your answer is what you want before you submit it. Okay, let's see here. Number 9, g of x equals the cube root of the quantity x minus 5. Find the function value if possible. Do not use a calculator. If the answer is undefined, enter undefined. So g of 32 would be the cube root of 32 minus 5, which is the cube root of 27, which is 3. All right, let's take a look at this one. The cube, simplify the cube root. So the cube root of negative 125 is negative 5. We had one just like this earlier. You can take the cube root of a negative number. You can't take an even root of a negative number. Let's see, how are we doing here? I want to skip down and make sure we get to some of these other ones. So let's see, what do we got? Okay, let's see here. Let's do this one. So we've got 32 x to the 10th, the whole thing to the 1/5 power. It says, simplify the expression if possible. Assume that the variable can be any real number and use absolute value symbols when necessary. If the solution is not real, write not real. We're taking a 5th root, that's an odd root, so we don't need to worry. So this is going to be 32 to the 1/5 power times x to the 10th to the 1/5 power. Well, the 5th root of 32 is 2. And x to the 10th to the 1/5, you'd multiply the powers. 10 times 1/5 is 2, so we get 2x squared. 2x squared. Let's go down. Let's take a look at, let's look at 18. 25 over 49 to the negative 3/2 power, which would be 49 over 25 to the positive 3/2 power, which would be 49 to the 3/2 power over 25 to the 3/2 power, which would be 49 to the 1/2 power cubed over 25 to the 1/2 power cubed. 49 to the 1/2 power is 7, so 7 cubed. 25 to the 1/2 power is 5, so 5 cubed. Let's see what we get here. 7 cubed is 343, and 5 cubed is 125. So fraction bar, 343, 125. Okay, let's see. Let's do 21. Simplify the expression. So that would be the square root of 25 times 5. The square root of 25 is 5 outside, so we get 5 square roots of 5. So we got 5 square roots of 5. Let's see. How about this? Well, let's do this one. They're all good problems, just a limited amount of time. The square root of 405 over the square root of 5 is the square root of 405 over 5 is the square root of 81 is 9. Let's do number 28. Simplify by combining like radicals. The square root of 245 plus the square root of 125 minus the square root of 320. So we need to simplify each radical. Well, let's see. Let's take 245. 5 goes into that. how many times? Let's see, if we take 245 divided by 5, we get 49. Oh, that's a perfect square, 49 is. So if we write this as 49 times 5, the square root of 49 gives us 7 outside. So 7 plus the square root of 5. Okay. 125 is 25 times 5. The square root of 25 is 5 outside. So plus 5 square roots of 5. And how about 320? Let's see, that's 5 times. Let's see here. 320 divided by 5 is 64. That's a perfect square. Square root of 64 is 8 outside. So I've got 7 square roots of 5 plus 5 square roots of 5 minus 8 square roots of 5. So they're all like terms. 7 plus 5 is 12 minus 8 is 4. So 4 square roots of 5. Let's see here. 4 square roots of 5. All right. The next one says solve the equation. So let's take a look at that. We've got the square root of 8x plus 17 equals 9. When we're solving an equation with one radical, we want to isolate that radical first. Since it's a square root, we'll square both sides and we'll get 8x plus 17 equals 81. Subtract 17 from both sides, 8x equals, let's see, what do we got here? 81 minus 17 is 64. Divide both sides by 8. X equals 8. Let's see if that checks. And it checks. So X equals 8. All right, let's take a look at number 30. Solve the equation, write all proposed solutions. If a solution is extraneous, so indicate. Okay. So isolating the radical, we get this. Well, already we're in trouble because the square root can't be negative, but going on, we get 2x equals 4. So x equals 2. But if we plug 2 back in, it doesn't work. So the proposed solution would be 2. It doesn't work, so it's extraneous. If it does work, you'd say not extraneous. Okay, and finally 31, solve the equation, write all proposed solutions, etc., etc. Okay, so we've got the cube root of x plus 5 equals negative 3. We've already got the radical isolated, so by cubing both sides, we get that. And we get x equals negative 32. Let's check our work. We get the cube root of negative 27 equals negative 3, and it checks. So we'll put in negative 32. All right. I know there's a lot of problems I skipped, but again, we're limited by time. If you have other questions, you can come to my office hour today, or you could actually come to class. I'll be reviewing again tomorrow, chapters 10 and 11. I will not be available this weekend. Your final exam is on Monday, and it has to be done by 11:59 p.m. Monday night. So there you go. Have a great rest of the day.